So what I'll do today is some examples from optimization, because if I recall correctly, we didn't do a tutorial on this. We had done just some problems in the class. So let me do a few today. If I found time, I felt better, and try to do one more tutorial or on something which you suggest you need to revise. Maybe something on Riemann integral as well. So let me just choose some problems from the book. So this is the problem set for optimization, which was exercises 4.7. And I just randomly chose a few. And so this is problem 62. And if you have the book available, you can have a look. So it says that the manager of a 100-unit apartment complex knows from experience that all units will be occupied if the rent is $800. And a market survey suggests that on average, one additional unit will remain vacant on average for each $10 increase in rent. So what rent should the manager charge to maximize revenue? So one always have to just think a little about what the problem is asking you to do. So first thing, you have some information about how much occupancy will be there as a function of rent. And it tells you that for an increase of $10, you have on average, one unit remaining empty for each $10 increase. So if for each step you get equal change in the dependent quantity for each extra increment, that means by definition that you are dealing with a linear function. So you have some kind of a linear relationship. If I plot rent here, which I'm calling R, and the occupancy, call that O, then you have at some $800 rent, your occupancy is 100. And then it falls. If you increase the rent, it falls linearly, something like that. And if I just extrapolate it, it's gonna cut the x-axis at some point. So I can find out that what's the, I want to get a relationship between occupancy and rent. So occupancy is a function of rent, and it's a linear function. So occupancy is a function of rent, a linear function, so I can just find out that what is that linear relationship. So I need to write the equation of the line in terms of these O and R. So I have this point here, which is 800 on the x-axis and 100 on the y-axis. And I need to find the slope. So what's the slope? So you have that as you increase x by 10, y decreases by 1. So it's minus 0.1. So now you can just write the equation of the line. Y I'm representing by O. O minus, I'm using this point, O minus 100 is equal to slope times x, which in this case is r minus 800, because that's the coordinate of this point for the x-axis. So I can now get this function O of r is simply minus 0.1 r minus 0.1 times 800 gives me plus 80 and plus 100. So this is the function. Now this person, the landlords, they don't want to maximize the occupancy, but that would be just 100. They want to maximize their revenue. So they would like to increase the rent a little bit, even if that means that some of the apartments are empty. So what do they need? Which function they want to maximize? To maximize is revenue. Let's call it R, and it's a function. How would you get revenues? You have occupancy times rent. That's your total revenue. So now you have, as I said, that in all of these problems, we will make the functions which we want to maximize into a function of only one variable. So I have this O in terms of R. I can just replace it here. Then R becomes minus 0.1 r square plus 180 r. And now you can find local extrema by just doing the derivative. So you get minus 0.2 r plus 180, and this you put equal to 0. That gives you that the rent should be 900. That would be your best rent. You can check that it's indeed a maximum, not a minimum. Well, common sense tells you that it cannot be a minimum. Minimum would be probably when you increase rent a lot and there's no occupancy. But it's a local maximum you can easily check by doing the second derivative, and that gives you minus 0.2 less than 0. So this implies that this point is a maxima. So you indeed have solution for your problem. Let me do 51. So it says that the illumination of an object by a light source. There are some questions over here. I can't show you the questions because I don't have the book in this computer. I'm reading them from the other book. So just listen to what I'm saying and I'll write down the main information. So the illumination of an object by a light source is directly proportional to the strength of the source. That's obvious. And inversely proportional to the square of the distance. So if you move away from the light source, how much light you receive, it goes down as the square of the distance. Because light is spread out on a spherical shell, and the area of sphere increases as the square of the distance. So the light you receive at a unit on a unit surface on this area will be reduced by the square of the distance. But you can just, this is just the information which is given to you. Now, if two light sources, one 3 times as strong as the other, are placed 10 feet apart, where should an object be placed on the line between the sources so as to receive the least illumination. So you have one light source, A, another light source, B. Let's say this one is the brighter one. I'm just assuming it has some units L that's telling me its luminosity, how bright it is. So it's 3L, maybe let's say 300 watts or something. And this is then just L. And on the line joining them, which is 10 feet long, at some point, you want to place an object. And if you will go in either direction, you will start reducing the light coming from one source and start gaining more light from the other source. So the question is where you should be placed so that you have minimum light falling on you. So again, it's it's exactly an optimization problem that there's a competition between these two light sources. So if you go near one, then you're getting more light, but you want to be away from the other one. So you want to find a compromise. Now, what you need is you need to write the how much light you get. I'm calling it intensity, I, as a function of x. If you find that function, then all you will need to do is maximize or minimize that function. So it was told to you that the intensity is proportional to the intensity. So let's say it's proportional, so I can include a constant. It doesn't matter even if you don't do it, it's just going to stay out. So it's proportional to the luminosity of this light, how powerful it is, divided by, let's say this is the distance I'm counting from here. This is x, then this distance is 10 minus x. So the intensity over here, because of the light coming from here, is 3L divided by x squared. So that's the intensity because of light source A. And because of light source B, you will get L over 10 minus x whole square. Now, all you need to do is find an extrema of this. So compute the derivative. And you get minus 6L over x cube plus L minus 2, 10 minus x cube, and there's a minus 1 from the derivative of 10 minus x. And this you're going to put equal to 0. So as I said, that k doesn't matter, and you get 6L for this condition to hold, for extrema to occur. 6L over x cube is equal to 2L over 10 minus x cube. So L, as it was an arbitrary unit, we should have expected that it will drop out, and it does. So you have x cube over 3 is 10 minus x cube, and x cube is, so x is this, and I can now solve for x. So I have x times 1 plus 3 to the cube root is equal to 3 cube root times 10, and x becomes this. if you compute this number, then you get, so the cube root of 3 is 1.4422. So you get 14.4 divided by 1 plus 1.44. So that's about 5.9. And I'm guaranteed that it's going to be a minimum. Why? I can do more work, but I can just use logic. That I have a 5, the middle point is here. I arbitrarily call this x and this 10 minus x. The x which I have gotten from here, I arbitrarily put 3L here. I could have put the 3L over here and call this x. Then this would not be a minima. This would actually be a maxima. Because what I can see over here right now is that I'm more away from the brightest source compared to the middle. So it has to be a minima. While if I replace the source's position, then I'll be closer to the brightest source. So there are two kind of extrema occurring here. Well, not two, there's only one, but you can argue that this is going to be now a minima. Now, let's do 52. So 52 says, find an equation of the line to point 3.5. So you have this point, 3.5. You want equation of a line that cuts off the least area in the first quadrant. So it would be some line. First of all, you can tell that if you want to have any area, any bounded area, finite area, bounded by this line on the first quadrant, then it better have a negative slope. But it will come out of your, should come out of your calculation. So something like this. The point is that if you tilt it more, you lose some area here and you gain some area here. So how much you should be tilting it, that's the question. So essentially, you're given the point, and all you need is the slope of this line, which will give you the maximum area under it. So essentially, you're computing the area of a triangle. So I have an equation of a line y minus 5 is equal to mx minus 3 because it passes through this point 3.5, but I don't know m. M is arbitrary at the moment. So you have y is equal to mx minus 3m plus 5. And so this line, now you have to find out where does it cut the x and y axis. Because then what you're going to do, so suppose it cuts it here, capital X, and it cuts it here at capital Y, then your area enclosed is just going to be the area of right triangle XOY, which is simply half XY, base times the perpendicular. So from here, I can find capital X. It's when y is 0. Mx minus 3m plus 5. So x turns out to be x, right? And on this same line, there's this point, which is 0, y. So I can find it from the same equation. When x is 0, y is equal to capital Y. When y is equal to 0, x is equal to capital X. So that gives me capital Y is minus 3m plus 5. So the function which I need to minimize now, was it minimize or maximize? Minimize. This function area, this is half xy, and this now becomes just a function of the slope. That's y, and x is 3 minus 5 over m. So if I compute Extrema, minus 3 times 3 minus 5 over m plus minus 3m plus 5 over m square, right? Okay, and this I'm going to put equal to 0. So if you can do this quickly, you get minus, I can get rid of this half, minus 9 minus 50, plus 15 over m minus 15 over m square and plus 25, no, yeah, plus 25 over m square is 0. देख लें कोई गलती तो नहीं. 3 times 3, 9, and half was outside. So minus 3 minus 5 over m. And so it seems like they cancel. And so I get m square, and m square is 25 over 9. So m is 5 over 3. Well, plus or minus, but the plus one is not going to give us a minimum, because that's going to give us a line which has infinite area under it. just by common sense, but you can do the second derivative and confirm that it's the correct choice is minus 5/3. प्लीज आप इनसे पूछेंगे इनके पास पानी है तो पानी ला दें सर प्लीज. So the 54 simply says that at which point on the curve, so you're given this curve, it's just a function, so it will have some graph. At which point on the curve does the tangent line have the largest slope? So slope is very easy to find. Slope of the tangent line let's call it m, and it's a function of x because it varies from point to point. So it's going to have some graph like this. So the tangents, they are changing from point to point. So the slope of the tangent is a function of x. I can write it like that. And it's found just by doing dy by dx. So minus 15 x4. That's the slope. You're not going to put it equal to 0 because that's the slope. If you put it equal to 0, that will tell you the point where the tangent is horizontal. You want where the slope is maximum. So we are maximizing this. So just take another derivative. And put this equal to 0. Thank you. So if I put this equal to 0, this has solutions. X is 0, or x square is 240 over 60. So that's 4. Is it? No. Yeah, it's a 4. I'm terrible with these small tables. So x is plus or minus 2. So at x is equal to 0 and plus minus 2, there's some kind of a extrema occurring. And we want to know, so since we have got 3 points, so we have to decide where it's going to be maximum or minimum. So we can just do the second derivative, because especially because that in this case it's kind of easy to compute that. The function is very easy. (180x). So now if I put x is equal to 0, then the second derivative is 240, which is greater than 0. Wait, this is not x, this is x square. But still, this conclusion holds. So it's greater than 0. So it must be a minima. But we don't want minimum, we want a maximum. So let's check what happens at other points. When x is plus or minus 2, is 240 minus 180 times 4, which is greater than, less than 0. So must be a maxima. So at both plus 2 and minus 2, you have local maximas. So at both local maxima, and so locally things can be maximum, but one local maximum can be bigger than the other. So if you have a bunch of local maxima, then you have to check each one of them for the values that which one has the bigger value. So that would be your global maxima. And since you are looking for a global maxima, you have to put this value back in the formula for the slope and see which one gives you a bigger number. But the slope in this case is an even function of x. So if you put plus 2 or minus 2, the answer is same. So that means both have same slope. So slope is maximum. Let me write. Since m of x is m of minus x, the slope takes same value at x is equal to plus 2 and x is equal to minus 2. And therefore, the maximum occurs is at 2 points, plus and minus 2.
Sir, how do you know that the slope is an even function?
Let's look at this one. So the question is, can you put the values of x in the equation of slope and check the largest slope? Yeah, that's exactly what I was doing. But you can put the critical values. Once you have critical values, then you can check which one is the largest. You're not going to check all the values which can be there. So problem 48. So there is a circular lake of radius this 1, 2, 3, 4, 5, 6, 1, 2, 3. A circular lake of radius 2 miles. And a woman is standing here at point A. She wants to cross the lake. Not only cross the lake, there's some shop here directly opposite to her. She wants to get there. And this is a circular lake of radius 2 meters. So which path she should take? Which is the smallest one? Any idea? If you want to go from A to B, which is the best path? Huh? Okay, but how is she going to cross the lake? Well, she has a boat. So if you had a boat, which one you would prefer? Would you rather row the boat or just walk? Well, if you ask me, I mean, I'm not good at rowing, so I will just walk. So then this one is a better path. But suppose your objective is to get fastest to the other side, then which one it will be? Well, it will depend on, because it's quite possible that you are not able to row very fast, right? And you walk, and this is still smaller, takes smaller time. But depending on how fast you can row, well, maybe you want to take this path so that you row for some time, not for the whole 4 miles, but for a smaller time, and then you walk, because you walk faster. If you walk faster, then you can ask, why can't I just walk all the way? Well, in that case, you will be covering a very large distance. So the overall time may increase even if your walking speed is faster than your rowing speed. So it's going to be a compromise that you want to row for some time and walk for some time. So you have to find a function that which one is going to be a best path. So suppose there is a solution to this problem. I'm finding this right down. ये इसमें साल मुझे लगता है पे खत्म हो जाएगा बोल दे अब I don't know. So is it clear that what's going on over here? The problem is that if you just row for the whole time, you have the least distance, but you are going at slower speed. If you walk the whole time, you are moving faster the whole time, but you have a larger distance to cover. So the overall time is some combination. Why this thing is here? So suppose there is some solution, I don't know which one is it. There's some point over here and you should walk there. There's a point on this circle. So let's say its coordinates are x tilde and y tilde. Thank you. You have these points x tilde and y tilde. So I'm just going to compute that when I choose, maybe if it's not even a solution. Let's just take that we have a point. We have different options. So we just for fun, she's gonna row in a straight line to a point x tilde, y tilde, and then walk along the shore. So when she walks, she has to walk along a circular path because that's going to be this shortest way. She's not going to walk through the water, so she's going to take a circular arc. So how much time it will take for an arbitrary point x tilde y tilde? It's not even a solution, but how much time it will take if he just does this, row and then walk? Well, you are given that she can row at 2 miles per hour, and she can walk at 4 miles per hour. So if there's this point x tilde y tilde, then this distance, if I have to set up some kind of, to compute the distances, I should set up some kind of coordinate system. So I can say that this is origin, because the circle is easiest to describe if I put the origin in the center. Because this point is on the circle, that for any arbitrary point, we have the equation of the circle is satisfied. So it doesn't matter which way she goes. She can go here and then walk. Or it could be this point, then she doesn't even row. She just rows for 0 seconds and then just walks. But this will be satisfied for all possible points. Now, what is her starting point? This is -2, 0, because the circle is of radius 2. So if you are on the left-hand side, then I'm going to call it, these coordinates are going to be -2, 0, and these coordinates are 2, 0. So what's the distance for which she rows? Rowing distance is, you just take these points, let's call it 0. So it's x tilde minus this x coordinate square plus y tilde minus the 0 coordinates, which is y coordinate, which is 0. So that's the rowing distance. However, this y tilde is not independent of x tilde. Once you have chosen an x, this y is fixed through this equation. So again, I'm finally going to maximize something, and I don't want dependence on 2 variables. So use this, use here. So that gives me that the rowing distance is x tilde square plus 4 x tilde. And please keep track of my calculation if I do something wrong. So I just used this, which gives me I don't know why I'm calling them tilde, but anyway.
Excuse me, sir. Sir, why is x tilde
So-
squared plus y tilde squared equal to 4?
These cancels. That's a good thing. It will be a simpler function. So I can take a 4 out. That becomes a 2. And I have x tilde plus 2 left hand side. So that's the distance, rowing distance. What's the rowing time? So I have v is equal to d over t. So t is d over v. So you take this distance. Well, let's give it a name, tr. So it's this distance over the speed. Rowing speed is 2. So this is just simply x tilde plus 2. Now, what about her? So please do keep a track, because in my notes I have just jumbled up everything. So I'm just doing it over here. Trigonometry will be, yeah, you can do it, but it would be quite hard. If you have better ideas, I didn't have any other idea. Probably there is some simple trigonometric idea. Now, what about walking distance? Now, to find the walking distance, what I'm going to do, I can use the arc length formula. So if I have, because this is a circle, and if I count from the center of the circle, if I can compute this angle in radians, then I know that the arc length is just r theta, if you are working in radians. So all I need to do is compute theta. That I can do by doing the tangent theta. So tangent theta is y tilde over x tilde. So first, let's find tangent theta, which is y tilde over x tilde. And y tilde is 4 minus x tilde square and x tilde. That means theta is tangent inverse over x tilde. So this becomes then r times theta. So it's 2 times tangent inverse over x tilde. Now, why don't you compute? Well, don't compute it for now. So that's the walking distance, and walking time is simply dw over the walking speed. So it's 2 over 4 So that means if I choose any arbitrary point, x tilde, y tilde, my total time to get to B is just the sum of the two times. So it's TR plus TW, and What was that? That was square root x plus 2. So let's call it time. This depends on this coordinates x tilde. So that's your total time, and you are extremizing this. So all you need to do is compute the derivative. So why don't you do it? This one is easy. This one, you should do it right now. I'm going to use Wolfram to compute it. Did I tell you about Wolfram? No? Maybe you know it. So did you compute it? So the Wolfram is telling me that it's not hard, it's very easy, it's just a couple of chain rules. It's telling me that it's this. Things cancel out and it's a very simple expression. It's a 4. This. But you should check how many have got it. People don't even have pens. So I get, if I use this formula, should we do it or should we just, huh? किसने किया? हाँ? कर लिया आपने? So if I assume that this is the correct answer, which it is, did you get it? X square over 4. That's it. That's wrong. That's clearly wrong. Iska. 1 over. Yeah. Cannot be true. Let's just compute it. Wolfram doesn't give you wrong things. It's been there for last 20 years. It's been perfected. Let me just write x tilde as x. So tangent inverse is 1 over 1 plus x squared. 1 plus x squared. So that's 4 minus x squared over x square. And now you start you're using the chain rule. That's the derivative of the chain rule and then the product rule on the chain rule. So this is right, okay, isn't it? Why not? You forgot the chain rule? You should fail this course. So when I simplify this x square goes up, and I have x square plus 4 minus x square. And I have square root of 4 minus x square over minus x square plus 2x is cancel, x square. These cancel. And when I take, let me bring this minus outside. And I take this. So I get 4 minus x square when I combine these fractions. And I had taken a minus out, so I have a minus here, x square. It should have been, एक second. बाहर एक 4 है और ये प्लस, so ये माइनस मैंने बाहर ले लिया था, so there was a minus here and no, they should cancel because according to Wolfram, if there's a relative negative sign, then these x's will cancel and I'll get exactly the answer by the Wolfram. So we have missed one minus sign. So when we were doing this product rule, so I have 1 over x, 1 by 2. Yeah, I missed this minus coming from the derivative of minus x square. Minus 1. So they are both minus, so this becomes plus. And they cancel, 4 cancel, and we get a very simple answer. So this is confirmed. Let's write it down over here. One over 2 under root x tilde plus 2. Was it downstairs or upstairs? Yeah, downstairs. And minus 1 over 4 minus x square. There was a half coming from here. And this is equal to 0. So that simply means 1 over or I can invert take a square. And this gives me x tilde square plus x minus 2 is 0. So solution is this correct? Just check it. Can be 5. It has to be inside the circle. And the internet is gone. Let's just, no one can factorize it. Minus 1 plus minus 1 plus 4 times 2 over 2 minus 1 plus minus 3 over 2. So minus 1 plus 3 over 2 and minus 1 minus 3 over 2. So this is 1 and this is minus 2. So what does this mean? This was the point. Well, you have 2 points. So the extremas occur. Minus 2 and x tilde 1. So if I look at this figure, minus 2 means, so this is the point up to which you row. So minus 2 means you don't row at all, you just walk. And that's an extrema. That is probably going to be maximum time taken. So if you choose this, take this choice that you're just going to walk, it will take the maximum time. Then the other one is clearly the minimum. And what it is, it's at this point, 1. X tilde 1, you row up to this point, and then you walk. So you know exactly which point over here, because x tilde is 1, you can compute what point is, you can compute this angle, at which angle you should row, and then when, how much, then you should walk. Let me stop here, and I'll try to do more tutorials before exams. And suggest me, well, I think probably a tutorial on integrals and Riemann sums. Did we do one? No? So maybe one on that. I'll try to do it tonight, probably. Okay.